Hello everyone, welcome to this video on dynamic memory allocation. Before going to dynamic memory allocation, we'll just brush up what we have done till now with respect to memory allocation. Now to make you understand better, let me take a very small program to add two numbers. Now what I am doing is I am basically reading values for A and B. Now whatever value that is there in A and B, I am storing their sum in a variable by name sum, and I will print the value of sum. Most easiest program, I think probably while starting the course on C language, you might have written such a small program to make you more convenient to know how exactly the concept of printf and scanf works. Now that in this particular case, what we generally do after writing the program, we go for the compilation. We do compilation. When we do compilation, what exactly the system is going to do is the system is going to allocate memory for the variables A, B as well as to the variable sum. So for all the variables that we are declaring in the function, that is in the main function, the system is going to allocate memory during the compilation time. Such a type of memory allocation is called as static memory allocation. Please note that in case of static memory allocation, the memory is allocated during the compilation time. Note that static memory, in static memory allocation, memory is allocated during compilation time. This is the most important point to be noted with respect to the static memory allocation. And generally in case of static memory allocation, the variables, for all the variables that we declare within a function will be taken memory from a region called as a stack. Hope you are familiar with the concept of stack. Generally what happens is, whenever you take the layout of a C program, that is whenever you take the memory layout of a C program, generally the memory layout of a C program constitutes of four different segments. The first segment called as the text segment, the second segment called as the data segment, the third segment called as stack, and the fourth segment called as the heap. Now, with respect to this particular program, all these variables A, B and sum is going to take memory from the stack region. That is, during static memory allocation, memories, the memory that get allocated during compilation time, the memory will be taken from the stack region. Now in this case, I have not wasted memory at all, because I have declared three variables A, B and sum. A, B and sum is going to take memory from this stack region. If I assume that an integer variable takes 2 bytes of memory, then this particular program, for this particular program, with respect to three variables, it takes 6 bytes of memory, and all the 6 bytes of memory is being used very efficiently. Now let me take one more case wherein I am doing some operation on an array. So let me declare an array of size 25. Let me declare a variable n, and let me have one more variable as I. So first what I will do, printf, I will read the number of elements. I will read the value of n. and then I will read those many elements. As I am reading the for loop from 1, I am iterating till end of maybe end of year, the value of n. Assume that okay, my objective of this particular program is to sort all the numbers that I have read using some sorting algorithm. It might be a bubble sort, or it might be a merge sort, or anything else. So what I will do, I will call the function by int sort, to which the argument says a comma n. Will not worry about okay, what exactly is the content of this function sort. Assume that okay, this function sort is going to sort all the elements that we are passing it to the array A. Now after this, what I will do, I will just print sorted elements are okay. Now I will not write the complete program with a for loop. Hope assume that I am completing this particular program. Return 0, close this particular function. Now even this is an example for static memory allocation, because I am allocating when I run this particular, after writing this particular program, when I compile, what happens is during the compilation time, the memory will be allocated for these 3 variables. Now for the variable I, okay, 2 bytes. For the variable n, now assuming that okay, integer takes 2 bytes of memory, for the variable n it takes 2 bytes. For array A of size 25, okay, it takes 50 bytes. 50 bytes. So totally, if you see, these three variables consumes 54 bytes of data, 54 bytes of memory from the stack region. Now, when I run this particular program, assume that the value of n that I have read is 10. But for n, that is, assume that during runtime, while running the program, my n will take 2 bytes. And if I assume that if value of n is 10, then what I am supposed to do? I am supposed to read 10 elements into array A. Now for this I, okay, it takes once again 2 bytes of memory. So for array A, how many bytes? As I am reading only 10 bytes, 10 into 2 is 20 bytes. 20 bytes. So totally it is 24 bytes of memory. Please note the difference. During compilation time, what I am doing is I am allocating memory of 54 bytes in my stack region. But while actually running the program, I am utilizing only 24 bytes of it from this 54 bytes. So how much is the wastage? Wastage is 30 bytes. So this is one of the drawback of static memory allocation. To overcome this particular drawback, we go for dynamic memory allocation. Hope the concept is clear. So this is about dynamic memory allocation. So note that the definition for dynamic memory allocation is if we allocate memory, that is memory allocation during the runtime or the execution time of the program is called as the dynamic memory allocation. So I'll just put out that allocation of memory during the runtime, or I can call it as the execution time. Is termed as dynamic memory allocation. And note that this dynamic memory allocation happens or occurs at the heap region. All dynamic memory allocation will be done from the heap region. Hope this is clear. This is about what do you mean by dynamic memory allocation. To support dynamic memory allocation, C supports some functions. Okay, those functions are, the first function is by name malloc, the second function is by name calloc, the third function is by name realloc, and the fourth function by name free. So this three function is for memory allocation, and the last one is to deallocate the memory. This is about what do you mean by dynamic memory allocation. And in order to do dynamic memory allocation, in case of C, we have three functions, namely malloc, calloc and realloc. The memory that was allocated dynamically can be deallocated using a function by name free. Note that, okay, this dynamic memory allocation function differs from one programming language to another programming language. In case of C++, there is an operator called new, which is going to perform the dynamic memory allocation. But in case of C, we use the most common function that we use to perform dynamic memory allocation is malloc. Hope it is clear. Thank you.